Okay, state the slope of each line segment. Express your answer as a reduced fraction. When we do slopes, we always will do it as reduced fraction, unless you are asked to express it as a decimal. Round it to the nearest whatever, usually tenth or hundredth, right? And that could happen in a numerical response question. We could also say, the slope is expressed in the form a over b. The value of a plus b is, right, to get a numerical response. Generally speaking, we always want it as a fraction, right, and then as a reduced fraction. Okay, what's the slope of AB? Is it positive or negative? Positive. All right, and it is what? 1, 2, 3, 4, 5, 6, 7 over 7 over 3. Right? All you're doing is counting on this. You don't need to do any fancy calculations. Okay, what's the slope of CD? Negative. Negative 2 over. Okay, so let's do we'll call it the raw slope, right? Just counting. So, maybe you count and you don't get the reduced slope right off the bat. Right? You're just counting between 2 points. Negative 2, right 6, and that's negative 1/3. What's the slope of EF?
0.
And what's the slope of GH? If you say 0, you'll get 0. Undefined. Vertical lines are undefined. For the lines shown, find the slopes of AB, BC, AC, and BD. Express your answers as reduced fractions. So what's the slope of AB? Okay, so let's start with 2 over 4. 1/2. Slope of BC? Okay, so we got 1, 2, 1, 2, 3. So slope of AB was never 2 over 4, it's 2 over 3. Could have sworn somebody said 2 over 4. What's the slope of BC? 2 over 3. What's the slope of AC? 2, 3, 4. 1, 2, 3, 4, 5, 6. What's the slope of AD? 6 over 9, which reduces to? What's the slope of BD? 4 over 6, which again reduces to 2/3. So what does that say? The slope of this line is 2/3, right? Slope of the line is constant. Wherever you calculate it from doesn't matter, right? Whether you do the slope from A to B, A to C, A to D, B to C, B to D, C to D, none of those matter, right? They're all the same. Slope of a line is constant. So what's true about these slopes? They're all the same. If you pick any 2 points on this line, what will be the slope of the line segment that connects these 2 points? 2/3, right? 2 over 3. The points A, B, C, and D are said to be collinear because they lie on the same line, which is really just the definition of collinear. If points P, Q, and R are collinear, what conclusions can be made about the slope PQ, the slope QR, and the slope PR?
They're equal.
They're all the same, yeah, they are the same. They are equal. They are all the same. Draw the line that passes through the given point. It says it passes the given point, so like it goes by it, but not through it. We'll say through the given point. Let's throw a through in here. Passes through the given point with the given slope. Label each line with its letter. Okay, now I'll do one with you, and then after that I'm sure you should be able to do the rest yourselves, right? But so I'll pause it and I'll do the rest, and then we'll put it back up again. So passing through negative 5, 6, this is how we're going to draw lines, right? So this is all part of how do we draw a line, right? And what are the characteristics of that line? So in this case, we know a point and we know the slope of the line. So how do we draw it? We find the point, so negative 5, 6. Put a dot there with the slope of negative 2/3. So I think of this two ways, this slope, right? I think of it as negative 2 over 3, which says go down 2 and right 3. So I'm going to do that. I'm going to go down 2 and right 3. I'm going to go down 2 and right 3. I'm going to go down 2 and right 3. I'm going to go down 2 and right 3. And I'm going to do that until I run out of grid. But I could also write it as 2 over negative 3. And what does that say? What am I going to do with this? What's this 2 say? Go up 2. Because the top number is rise. If the rise is positive, you go up. We have a sheet here. If the rise is negative, we go down. The bottom number is the run. If the run is positive, we go right. If the run is negative, we go left 3. So from this point, I can go up 2 and left 3. Not such a big deal for this particular line, right? Because really we were almost in the upper left. But had we started with a point down here where we weren't able to go down to the right for a positive slope, then we would need to also know that a line that goes down to the right goes up to the left. Okay, and now we can join those points with a straight line, and we put arrows on each end. And we label this, label each line with its letter. I guess this is little a. Okay, let's do one more together, and then you can do it. So passing through negative 7, negative 2, with a slope of 5 over 4. So I'm going to switch pens here. Negative 7, negative 2, with a slope of 5 over 4. So that says go up 5, 1, 2, 3, 4, 5, and right 4, 1, 2, 3, 4. And go up 5, and 1, 2, 3, 4. I can't go down 5 and left 4. I can go down 5, but it won't fit on the grid. So what I want to do, when I draw these lines, I fill the grid with points. Okay? So I go all the way up. If it's positive, I go all the way up to the right. I go all the way down to the left. If it's negative, I go all the way that I can down to the right, and all the way that I can up to the left. I want as many points as I can get. I join those points with a straight line. You can do a better job of because you're not working on a vertical surface. And there we go, and that's little b. Okay, so I'm going to hit pause. I'm just going to work through the rest of this. So slope's negative 5. I write that as negative 5 over 1. Plot the point 2, 8. Go down 1, 2, 3, 4, 5 down. And 1 to the right. Go 1, 2, 3, 4, 5 down. 5 down. There we go. Got as many points as I can. Try and join them with a straight line. Not likely to happen. That's D. That's C. Let's go black for E. Passing through 5, 4. 5, 4. 5, 4, 5, 4, 5, 4. Slope of 0. Horizontal line has a slope of 0. So that's E. And let's go back to red, I guess. Passing through 7, negative 4. 7, negative 4. With a slope that's undefined. Undefined slope, vertical line. And that's F. Alright, let's move on. I'm going to assume you've got that right. If I messed anything up, you let me know. Draw the line that passes through 0, 0 with a slope of 1/3, 1/2, 1, 1, 1, which I think of as 1 over 1, and 4. So 1 over 1, 4 over 1. Draw the line. Well, there's not really the line. Draw the
There's a
lines.
lot of students coming in late this morning. Please accept them into your class. We've just had 2 buses come right now.
No, we will deny them entry. Sit in the hall. I'll teach you. If you'd have gotten up 2 hours early and walked, you'd have been here on time. I always wonder why, are there teachers that actually lock you out in the hall? I don't know, I'm asking. Okay, pass through 0, 0 with a slope of 1/3, so 0, 0, up 1 over 3, up 1 over 3, up 1 over 3, down 1, left 3, down 1, left 3, down 1, left 3. Okay, 1/3 is either positive 1 over positive 3, which is up 1, right 3, or it's negative 1 over negative 3, which is down 1, left 3. Okay? So there's the first one. 1/2. I guess I can use different colors here. Right? So here, that'll be purple. Go for the thin red line. Slope of 1/2. Positive slope again. Go up 1 over 2. Up 1 over 2. Up 1 over 2. Up 1 over 2. Go down on this point here, right? Go down 1, left 2, down 1, left 2, down 1, left 2, down 1, left 2. Down 1, I can't go left 2. Okay, let's go green. I don't have a thin green line on here. All right. Slope of 1. Up 1 over 1, up 1 over 1, up 1 over 1, up 1 over, up 1 over, up 1 over, up 1 over, down over, down, go down, down. Slope of 1. 5/2. Up 5, right 2, can't go up 5. Down 5, left 2, can't do that again. So now I have just 3 points this time. And, I guess we'll go black for that one. So 4 over 1, up 4 over 1, up 4 over 1, down 4, left 1, down 4, left 1. All right, you got them all drawn? Now I just see the tops of your heads. So. We'll pause whilst you. I drew them all. I don't know what's holding you back. You're working on a nice horizontal surface. Since all the slopes are positive, as we go from left to right, the line goes up. Up. That's the movie my daughter skipped her grad banquet to go see. As the size of the slope of the line increases, the line gets steeper. Okay, so what we have? We have 1/3, 1/2, a 1, a 5, 2.5 or 5/2, and then 4, where we can see this line is getting steeper. Okay, so as the slope, as it gets more slopier, it gets steeper. All right, let's move down. Bet you we do this with negative now. Draw the line that passes through 0, 0 with slope negative 1/3, negative 1/2, negative 1. Again, I like to put it over 1 just because I like to have a rise and a run. Okay, so I know, okay, the rise is this, the run is that. So I won't bore you with the details. I'm just going to draw these. So we'll pause this now. So even if you're not here, I'm obviously not addressing you. Since all the slopes are negative, as we go from left to right, the line goes. As the size of the slope of the line increases, the line gets steeper. Okay, so we go down and the line gets steeper. Next page. The line shown intersects the x-axis and the y-axis. State the coordinates of these points of intersection. Okay, what are they? Give me one of the points. Pick a point, give me the coordinates. 0 and? Somebody say the right answer. No. 0 and? Thank you. And the other point is? 6, 0. You need to get straight what's what, right? The first coordinate is your x coordinate, that's your left, right. The second coordinate is your y coordinate, that's your up, down. So this point is 0, don't go anywhere left or right, but go down 4. And this point is go right 6, but don't go up or down. Use these points of intersection to find the slope of the line. Well, that's easy, we just got to count, right? 1, 2, 3, 4, because we got points. Here are the points. So we go up 4 and right 6, which we could say is 2/3, right? Always reduce the slope, that way we're all, I mean 4 over 6 is the same as 2 over 3, or 3 over 9, or 8 over 12, or all kinds of things, right? But if we say 2/3, then we're all talking the same number, in the same, Why do I record myself sounding like an idiot at times? The x-coordinate of the point of intersection of the line and the x-axis is called the x-intercept. State the x-intercept. 6. Remember, we've done intercepts, right? Pretty sure we've done it. Have we done intercepts? Yeah, we talked about intercepts. It's always hard to know what you know and what you don't know. So remember, intercepts are just numbers. They're not the point, right? It's just the x-coordinate of the point of intersection. The y-coordinate of the point of intersection of the line and the y-axis is called the y-intercept. State the y-intercept. -4. Draw a line with x-intercept 7 and y-intercept 5. Okay, x-intercept 7 and y-intercept 5. And how many points do we need to draw a line? 2. So we've got 2. All right, we're going to draw this. Yeah, good luck. Hey, that wasn't actually bad.
It's horrible.
I need a few practice strokes first, right? It's like golf. A few little. What is the slope of this line? Well, you go down 5 and right 7, so it's -5 over 7. Okay. Now, so we'll write this like this: -5/7. So this is what I write. This is what I think. I go down 5, right 7. Or I go up 5, left 7, right? So when I'm thinking about its negative slope and drawing it, I always think of it as, well, it's -5 over +7. Go down 5, go right 7. Or it's +5 over -7. Go up 5, go left 7. Right? That's what it tells me. State whether each line has a positive slope, a negative slope, a zero slope, or an undefined slope. A line with a negative x-intercept and a positive y-intercept. You guys are good. I got to draw this out. So let me see. A negative x-intercept and a positive y-intercept. Yeah, look at that. Okay, positive. A line with a negative y-intercept and a negative x-intercept. Negative. A line with no x-intercept. A line with no y-intercept. You say 0, I'll give you 0. Undefined. Yeah, it's vertical. It's a vertical line, right?
Why is it undefined?
Because you can't define it. Because you can't divide by 0. The run is 0. Division by 0 is undefined. A line segment is shown. Ask me later. I'm not going to get into a discussion now. Not one of these. But why? Why is this guy? Because the reflection is but why? Because but why?
Because physics told us.
Yeah. A line segment is shown. The dependent variable is y. The independent variable is y naught. I mean x. Well, it's not y, so it must be x. The rise is the change in the dependent variable, which is the change in y. This change is denoted by, how do you read this? Delta.
Yay.
Delta. It's a Greek letter delta. It is used to denote the change in. You're going to see this a lot. So this change is denoted by delta y. Use the graph to find the rise. All right, what is the rise? Let's go with 4. The run is the change in the independent variable, which is the change in x. This change is denoted by delta x. Use the graph to find the run. 5. State the coordinates of the endpoints. A, 3, 2. B, 8, 6. I got 8, 6. You get 8, 6? Using only the coordinates of the endpoints and not the graph, how can you calculate the rise?
8 minus, or 6 minus 2.
So difference in y coordinates, right? Using only the coordinates of the endpoints and not the graph, how can you calculate the run? Difference in the x coordinates. For the points P2, x2, y2, and P1, x1, y1, write an expression for the rise. It's going to be, write an expression for the run.
X2 minus x.
Write an expression for the slope. M equals rise over, which is the change in, over the change in x, which is
Delta y.
delta y, which is okay, so slope is defined as rise over run, which is the change in y over the change in x, or delta y over delta x, which is y2 minus y1 over x2 minus x1. And that's the slope formula. Use your slope formula, which happens to be the slope formula, to determine the slope of the line passing through E, negative 3, 6, and F, 5, 2. So here's what we're going to do. We're going to write down the formula. All right, what's y2?
2.
y2 is 2. What's y1? What's x2? What's x1?
Minus 3.
Okay, so as soon as you choose y2, everything is locked in. If 2 is y2, then 5 is x2. And then 6 is y1, and then negative 3 is x1. Okay. What if you use these same coordinates to show the order in which you subtract the coordinates does not matter? Okay, so again, what if we said y2 minus y1 over x2 minus x1, and this time you chose to say 6 was y2. That would make 2 y1. That would make negative 3 x2. That would make 5 x1. So this would be 4 over negative 8. Okay? So it doesn't matter what order you go in, right? It doesn't matter which point you say is point 1 and which point you say is point 2. As long as you're consistent, right? You have to say, if that's point 1, this is x1, y1, and the other one is x2, y2. I can't change them around, right? If I do, then I get a different slope. It would not be the correct slope. So another thing you can do is, right, we're just using slope, but if you want to have an idea, you can say, well, okay, negative 3, 6, that's about there, and 5, 2, that's about there. So this line should have a negative slope, right, just sketching it out. Okay, so you can use that to kind of check yourself, right? Yeah, okay, that line should have a negative slope. I'm calculating a negative slope. All is good. Wow, how long does this keep going for? Wow. Well, that we're doing parallel and perpendicular lines too. Use the slope formula, m equals y2 minus y1 over x2 minus x1 to determine the slope of the line that passes through each pair of points. Okay, well, that'll be really boring to, sit and work through if somebody has to watch this. So I'm just going to pause this, and I'm going to give you a head start, and then I'm just going to work them out. But I'm going to give you a head start so you can work them out. Okay, so you can check all your answers now. Why are you guys still writing? Good. Congratulations. How slow are you? It's a long way towards explaining why you take so long on tests. You don't know the material well enough to work through it quickly, accurately. Guy used to teach here named Mr. Bold, whose wife now teaches here, Mrs. Bold. But he used to say you need to be crisp, right? Like you need to be able to look at something and figure out exactly what it's asking and know exactly what to do, not have to sit and think about it, right? Like, am I supposed to add up this series, or am I getting the total number of things? Is that the sum? What kind of series is it? Right? As you look at it and you go, this is an arithmetic series. The word total is in there, which tells me that I'm adding. I'm using one of the arithmetic series formulas. Which one fits what I have? Z and done. What? I mess up? Which one? What did I get wrong?
I got 0 over 5.
That's fine. Still 0.
F is wrong. You put, I lied. I lied. Okay, now.
So f could be 0 over 5, it could be 0 over negative 5, but ultimately it's 0, right? So it doesn't matter. Recall that if P, Q, and R are collinear, then the slope of PQ is equal to the slope of QR is equal to the slope of PR. Use this to determine whether or not the following points are collinear. Note that you only have to show that 2 of the slopes are equal, right? Because if you show that PQ, so let's say we had so if this slope is the same as that slope, then we know that they're collinear, or if PQ is the same as PR, etc., etc. All right, so we gotta work out some slopes. Let's pause this. There we go. Okay, so first one was collinear. I worked out all 3 slopes, but again, you only need 2 out of 3, right? Because 2 out of 3 ain't bad. And here, as soon as I get 2 different slopes, then I can say, well, those lines are not collinear, right? They can't be. And we could work out the slope of JL as well, right? And again, it wouldn't matter. It wouldn't be the same as either. So for collinearity, you need 2 out of 3 slopes to be the same. For AB and C, determine the slope of AB. Okay, so MAB is, I don't know, what order? I just pick random orders, whatever I want to. So 3 minus negative 4 over 5 minus 2 is what? 1/3? 1/3. Said with such conviction. Like 1/3. Write an expression for the slope of BC. And in this case, it's an expression, right? We can't determine it because there's a variable in there. So the slope of BC is equal to, so if I'm going to do this, let's go with 1 minus negative 3 over x minus 5. So 4 over x minus 5, right? And similarly, you could have negative 4 over 5 minus x. They would be equivalent expressions, right? If A, B, and C are collinear points, what can you say about the slopes of A, B, and B, C? They are the same. So pretty much the answer to half the blanks on our worksheets are they are the same.
Is that the same on the test?
Nope.
Aw.
Use your results from part A and C to determine the value of x. So what am I going to do to determine the value of x?
4 over x minus 5 equals 1/3.
Okay, how are you going to solve that?
Cross product.
Cross product, really? Cross multiply, whatever, okay. So 4 times 3 is equal to x minus 5. X minus 5 is 12, so x is 17. Yay, hooray. Hoorah. Determine the value of y if negative 2, 4, 6, 0, and 8y are collinear points. Okay, you do that, like, pause. Agree, disagree? Agree, good. Keep going. Determine the missing value if the line segment joining the given points has the indicated slope. See, now here's the thing, right? Well, if it's wrong, let me know. Here's the thing. When I'm going to write this slope of negative 2/3, I'm going to have to choose where do I want the negative to be? Because I what?
Should it be x minus 1?
I don't know. Should it be?
Then it would be x plus 1.
Okay. Cool. That's what you guys are here for, right? Point out errors. Speak up. Have the courage of your convictions. All right, so I am going to, because that x is negative, I'm going to put the negative with the 2. Because then it's going to multiply and turn that into a positive x, right? It just saves me a little bit of work in the end, right? It won't make no difference. Ultimately, it makes no difference, right? And I might as well just write that as negative x minus 2. Okay, so we get negative 2 times negative x minus 2 is equal to 12. So 2x plus 4 is 12. All right, maybe I should make a mistake on purpose this time. You know what, let's do y minus 6 instead. Yes? No? Maybe snow? Because, snow. It's like it just cleared away, right? Like the snow just gone, right? You look out in front of your house, the lawn was now back to brown and whatever, right? No snow. And then, boom, back to winter wonderland, right? Just in time for tonight's football game. Thanks, guys. But, take heart because it's not going to be as cold as when the seniors play on Saturday. Plus, the juniors have a pretty decent shot of winning, and the seniors, well, I wish them all the best. I would not bet money on them unless I got really, really, really good odds. A line segment with slope negative 1/2 has one endpoint at 0, 4. If the other endpoint is on the x-axis. Okay, so you got to think about this, right? The reason you do homework.